welcome to the practice problems video for differentiability and tangent planes. Okay, so we're going to find an equation of the tangent plane to the graph of f of xy is equal to x squared times y plus x times y cubed at 2, 1. Okay, so first of all, let's start with the general equation of the tangent plane. So that's going to be that Ly, L of xy, also equal to z, the height, is equal to f of AB plus f sub x evaluated at AB times at x minus a plus f sub y evaluated at AB times y minus b. Okay, so in this sense, in this problem, we have that a equals 2, right? And we're given that b equals 1. So what we're going to have is actually that z is equal to f of 2, 1 plus f sub x of 2, 1, x minus 2 plus f sub y at 2, 1, evaluated at 2, 1, and then y minus 1. Okay? Alright, so our job here is now to find f of 2, 1, f sub x of 2, 1, and f sub y of 2, 1, and then we can just solve through. Okay, so first of all, f of 2, 1 will be obtained by just plugging 2 and 1 in for x and y in our original function. Okay? So we have 2 squared times a 1 plus 2 times 1 cubed. So that's just going to equal 4 plus 2, which is equal to 6. Okay? And then the next thing that we have to find is our f sub x. Okay, so f sub x is going to be equal to the partial derivative with respect to x of our original function, which is the following. Okay, and then when we differentiate with respect to x, what we'll get is a 2xy and then plus y cubed. So f sub x at 2, 1 is then 2 times 2 times 1 plus a 1 cubed, which is going to be equal to 4 plus 1, so that would be a 5. Okay? Alright, and then lastly we have our f sub y, so that would be the partial derivative with respect to y of our original function. So that's going to be, if we hold x constant, that'll just be an x squared plus 3x times y squared. Okay? And then when we plug in our 2 and 1, we get 2 squared plus 3 times 2 times 1 squared. So that'll be a 4 plus 6, which is a 10. Okay? So now we found all three values, and we can just plug them in. So we have a 6 for the first one, a 5 for the f sub x, and the 10 for the f sub y. Okay? And I'll continue this on the next slide. So now what we have is that our z, or our L of xy, is equal to a 6 plus, and then for f sub x evaluated at 2, 1, we got a 5. And then we had our x minus 2 sitting there. And then for the f sub y, we got a 10 when we plugged in 2, 1. And then we had y minus 1. So at this point, we can just simplify out. So we'll get z is equal to 6 plus 5x minus 10 plus 10y minus a 10. Okay? So what we're going to get is z is equal to 5x plus a 10y. And when we combine the constants, we get 6 minus 20, which is a negative 14. So we could either take this answer here, that is perfectly fine, or we could even rearrange a little bit just to say that we have 5x plus 10y minus a z is equal to 14, just to get all the variables on one side. So either answer would be correct, and that's pretty much it.